seconds is called the current. So the current is equal to charge by time. This is the electric current. This is the electric current. This Q is the charge and T is the time. So electric current is rate of flow of charges, means how much charges have flown within a span of time. It's a scalar quantity class. Electric current is the only scalar quantity which has a magnitude and a direction. But why don't we include under the vectors? The reason is that they do not obey the vector laws. For a quantity to be called as a vector, there has to be three conditions which have to be followed. First condition is that it should have a magnitude. So charges have magnitude. Second condition is that they should have a direction. So electric current has a direction. So till here, all the conditions are obeyed. The third condition says that it should follow the vector laws, means your parallelogram law, triangle law, all the other laws of the vector. Here the charges of electric current, basically current, fails to comply by the laws. That's why, because of this limitation, charges have the magnitude, they have the direction, but they do not have the vector form. So SI unit is amperes. A is the symbol. Write it down the initial part first. Done? Let us come to the direction of current. And see, the magnitude is this. This is from the magnitude. As discussed, it's a scalar quantity, but it will be having the magnitude and it will be having the direction. So magnitude is calculated in this way. What about the directions now? See, this is completely about the charges, the flow of charges. So if the charges are positive, positively charges we have. So it's suppose this is moving with velocity v. The protons are the best example for positive charges. Right? Protons are the best example for positive charges. So for positive charges, the direction is same as that of the charges. Direction of current and direction of charges are same. But for a negative charge, for example, electron, the direction is opposite. That is anti-parallel. So if you are having an electron which is moving towards the right, the direction of current will be towards the left. But again, I'm repeating, this is considered as scalar because it does not obey the vector laws. So we cannot consider and calculate it under the vector quantities. Now comes the case of this elaboration of the magnitude also. See, you know a time duration. Time duration means, let's say 0 to 8 seconds, 0 to 2 seconds, 8 to 9 seconds, like this. This is a duration that we have, a particular duration that has a beginning and has an ending. So this is a particular time duration which we are referring to, 0 to 8 seconds, 0 to 2 seconds, 8 to 9 seconds, 3 p.m. to 4 p.m. Like this, we are having all the time duration present. Who is this Nazia? Who is this Nazia?
Ma'am, it's me, Mariam.
Nazia, this is your first class?
No, ma'am, it's me, Mariam. Can you hear me?
Okay, Mariam. Just rename yourself, otherwise it becomes very confusing. So this is a time duration which is present. So once we are having this time duration which is present, now what will happen? We will be solving it using the average current. Means you will take the difference of the charges by the difference of the time. How to calculate this? Change in charge. Change in charge can be calculated by the final charge minus initial charge. This will give you the amount of charges. Similarly, time duration will be calculated by final time minus initial time. So this is the time duration. So final charge minus initial charge, final time minus initial time. This is Mariam Batul, right? Mariam, just put your surname because there are 3 Mariams in this batch.
Okay, ma'am.
Okay. Mariam Lohani, Mariam Batul, Mariam Mohammed. So just put your surname. Otherwise, I'll not be able to figure it out which Mariam is this. So this is final charge minus initial charge. This is final time minus initial time. This current which we are getting, we are calling it as the average current. We are calling it as the average current, where you have the duration of charge, where you have the charges flowing for a particular duration. Now, second case, which is followed by the time duration, is the time instant case. Time instant case means at a second of time, at one instant of time. For example, if I say t is equal to 0.001 seconds, or if I say t is equal to 8 seconds, or t is equal to 2 seconds, a particular time instant. Here we cannot calculate the average current. Here we have to calculate the instantaneous current. And how do we calculate any instantaneous quantity? Your algebra does not work over here. You have to integrate or differentiate it. So in this case, we have to differentiate the amount of charges flowing per unit time. So you have to differentiate, and the current that we get is the instantaneous current. So you have 2 types of currents, instantaneous current and average current. Average current you'll use when you have the time duration, and instantaneous current when you have a particular time instant. I'll show you this question. You will tell me the answer, both the parts. First, write it from here. Okay, yeah, has answered. See, charge is given to us. Q is 3t square plus 2t plus 1. So in the first part, we have the time between 0 to 2 seconds. So this is a duration which we have. This is not a time instant. This is a time duration which we have. So in case of time duration, I have told you that we calculate the average current, not the instantaneous current. Average current means you put in the values of the time to get the values of charges. See, what is our Q initial? Initial time is 0. So put 0 here. 0 square plus 2 into 0 plus 1. So this becomes just 1 coulomb. Then we'll substitute the second time. Second time is 2 seconds, which is 3 into 2 square plus 2 into 2 plus 1. So this is 4 into 3, which is 12. 12 plus 4, 16 plus 1, 17 coulomb. So initial charge, final charge. And what about the time? Initial time is 0 seconds. Final time is 2 seconds. Right? What have we studied about the average current? Average current is Q final minus Q initial divided by final time minus initial time. So this becomes 17 minus 1 divided by 2 minus 0. This becomes 16 by 2, which is equal to 8 amperes. This is equal to 8 amperes. So Yahiya's answer was correct. Rest nobody has answered. In the second part, okay, yeah, good. Other students also, if you have your answers, please share. This is at 2 seconds. So at t is equal to 2 seconds, we have to differentiate it because when you are talking about at t is equal to 2 seconds, this means we are calculating the instantaneous current. For instantaneous current, we differentiate. This is dq over dt. So our equation, which is 3t square plus 2t plus 1. So when we are differentiating it, dq over dt, this becomes 6t plus 2, right? Hello. Now you substitute in the value of at t is equal to 2 seconds. So current will be equal to 6 into 2 plus 2. So this is equal to 12 plus 2, 14 amperes. So see the difference between the values of instantaneous and average current. Write down the solution quickly, all of you. So yes, both answers were right. An electron is revolving around the nucleus with the frequency nu. Calculate the current. See, what is the formula of current that we've studied? It is charge divided by time. Now, time is equal to 1 by frequency. And the charge that has been referred here, it's the electronic charge. This is the electronic charge, which is 1.6 into 10 to the power minus 19 coulomb. Right? So once you substitute all these values instead of 1 by time, see, I can write charge into 1 by time. And what is 1 by time? Frequency will be 1 by time. The way charge is, time is 1 by frequency. So frequency is 1 by time. This new symbol stands for frequency. So instead of 1 by time, we can put it as Q into nu. And for charge, we can write it as electronic charge into the frequency. For n number of n number of electrons, this will be n e. This comes as a 2 marker. This is not very important. Just write down this. Any questions if you have, let me. It's just related to frequency. See, the next concept is the drift velocity. What is drift velocity? Drift velocity is basically the velocity of the moving charges. Now understand this concept first. This is just a bigger section of the wire which we are drawing. A thicker, bigger section of the wire which I'm drawing. So wire is just thin wire. It's just I have drawn it to show the amount of charges. So within a wire, there are many things which are present. So you have the positive charges which are present. Like this, you have the positive charges which are present. In between them, ions are present. When we take the broader aspect of the structure of the wire, these positive charges are present. In between them, electrons are present which are moving. Not only moving, these electrons, they are colliding with these positive charges. They are colliding among themselves. They are colliding with the walls of the container, and they're colliding with all the positive ions and all the charges. This collision is occurring. Now what happens? Under the influence of electric field, when this entire setup is substituted, and all the electrons are moving, all the electrons move in a single direction. All the electrons move in a single direction. Basically, they drift. So this velocity with which all the electrons are drifting towards one direction is called as the drift velocity, because these electrons are drifting. And see, every electron is having its own velocity. Let's talk about this particular electron. See, this is having V1 velocity. This electron is having V2 velocity. This is having V3. This is having V4. This is having V5. And for nth number, we have V nth present. So nth number of electrons and charges, they are present. So when the electrons are moving within the wire, which velocity will you categorize as the final velocity? We cannot choose one velocity out of all these. So what should we do when variable and varied varieties of velocities are present? We take the average of them, so that we can say that one single velocity is being flown through this wire. That single average thermal velocity, it is called the drift velocity. So we have to ultimately calculate the average of all the electrons which are present. And see, average thermal velocity, because initially all the electrons are at rest. So initially the thermal velocity, this is 0. Fine. Why? Because initially the electrons were at rest. After connecting the entire circuit, when the battery was connected, switch was on, because of the influence of electric field and potential, the charges then began their motion. That's why initial velocities are 0, but we have the final velocities. Fine. So this average thermal velocity is 0. U1, U2, UN, these are the thermal velocities of electrons. Thermal velocity means the initial velocity of the electrons. This derivation is very important, class. This comes as a 5 marker. Now, what is drift velocity? Velocity with which electrons drift towards the positive end of conductor due to application of electric field. Fine. See, force is equal to, when we are talking about the forces, force is QE. Also, we know force is equal to mass into acceleration. So acceleration would be force divided by mass. So final acceleration will be E, that is the charge electrons. We are talking about the electrons only. Drift velocity is about the electrons, not about the protons or the positive charges, because they are static. It's the movement of electrons which creates the current, electricity. So electric field divided by the mass. Mass is of the electron. Fine, this is the acceleration. So this is about the introduction of drift velocity. Until here, we have just found the acceleration of the charges, E by M. Now look, T1, T2, these are the relaxation time. Now what are relaxation time? When two electrons collide among themselves, they stop and take a break of very, very few seconds. 10 to the power minus 39 and this much seconds, very short duration. This span of time where the electrons are not colliding and are preparing for the next collision, this is called as the relaxation time. This is known as the relaxation time. So there are so many electrons present and so many collisions occurring. So how can we consider all the relaxation time? So we calculate and take out for all the electrons which are present, we take the average relaxation time. We calculate the average relaxation time. The way we are calculating the average velocity, so we have to consider the average relaxation time. Now see, using our first equation of uniformly accelerated motion, we have V is equal to U plus AT. So for the first electron, V1 will be U1 plus A, tau 1. Tau 1 is the relaxation time between the first electron. For the first electron. Similarly, for two electrons, for the second electron, we have V2 is equal to U2 plus A T2, like this. So still nth n number of electron, Ne, we have Vn is equal to Un plus A tau n. All right, so now what we have all the individual velocities. What have I discussed with you? Do we calculate the individual velocities? We calculate the average velocity. So we have the individual velocities now. We'll calculate the average velocity. So how do you calculate average? If I have three marks, the marks of three students, and I have to calculate the average, I'll add all the marks and divide it by 3. If we have n number of electrons and n number of velocities, I'll add all the n number of velocities and divide it by n. So this is the procedure which we are left with now. So drift velocity V1 would be U1 plus A tau 1 plus U2, second velocity would be U2 plus A tau 2. U3 would be U3 plus A tau 3 up till UNth plus A tau nth divided by n. Let's do one thing. Let's bring all these initial velocities term separately. U1, because they are just getting added, nothing is being multiplied. So we can interchange U1 plus U2 plus U3 up till UNth divided by n. Plus here we have acceleration tau 1 plus acceleration of tau 2 up till acceleration of tau nth by n, right? Now class, in the beginning only I have told you that the initial average velocity is 0. So this term becomes 0. We are left with this. Let's take acceleration form. So we are left with tau 1 plus tau 2 till tau nth divided by n. Class, what is this? We are adding all the relaxation time and dividing it by the number of time. So basically this is average relaxation time. This entire bracket, this is tau wave, which I am writing now. This tau stands for average relaxation time. This stands for average relaxation time. So I'll substitute it with just this tau. This tau is symbolizing acceleration time. Fine. So we are having acceleration into time. Now acceleration's value we have calculated initially, EE by m. Let's put it here. So drift velocity will become EE tau by m. This is the value of drift velocity. Let me write it in the center so that I can write all the terms together. Drift velocity is E tau by m. We can put a negative sign also for electron. So what is VD? VD is the drift velocity which we have calculated. It's the average velocity of all the electrons with which they are drifting towards the positive terminal under the influence of electric field. What is E? E we have studied so many times. It is the electronic charge. which stands for 1.6 into 10 to the power minus 19 coulomb. E is the electric field. Under the influence of electric field only this is occurring because of the substitution of battery and voltages. Tau is the average relaxation time. So basically time will be given to you. That time you have to substitute. This is average relaxation time. And what is M? M becomes very confusing whether it's the mass of conductor or mass of electron. Remember, it's not the mass of the wire or the conductor in which the electrons are flowing. It's the mass of electrons. And the mass of electrons are always definite, 9.31 into 10 to the power minus 31 kg. Or rather than 31, we can just write 1. We can just write 1. So 9.1 into 10 to the power minus 31 kgs. Minus sign also you can substitute. Minus sign also you can put. This minus sign will be showing that this is in the opposite direction of electric field, but you can avoid it for the time being. If it comes, we'll discuss this. So this is your drift velocity, and it's a very important derivation of your syllabus. You have many portions related to drift velocity. See class, individual questions from drift velocity in terms of numericals are least, but this gets related with some other relations. So drift velocity's derivation is important and it's lengthy also. So it comes as a huge marker questions, not your 1 or 2 marks. Class, tell me, is this portion entire derivation clear to all of you? Give a thumbs up. All of you who have understood. Any doubts if one has? Mariam, it's clear. What about Khadija? Nuha, what about you? Is it clear or not? Soha? All right, write it down. Any doubts? If you're getting any doubts in between, you can always ask. Write it. See, when we are talking about drift velocity, if the temperature increases, tau decreases. That is, our average relaxation time decreases. And see, in the formula, we have seen that average relaxation time is directly proportional to drift velocity. So if tau is decreasing, drift velocity will also be decreasing. And vice versa will be happening. If the temperature is decreasing, tau will be increasing and drift velocity will be increasing. So just remember this. Now there is a relation between the current and the drift velocity, which is more important than the derivation of the drift velocity, which is the relation between the current and the drift velocity. It's a very small derivation. See, this is the conductor where the electrons are flowing. A is the area of the cross section and L is the length of the wire. So just a second. So see, we have a wire, electrons are flowing, length of the wire is L, the area of the cross section. Cross section means this part. This is A. N is the number density of electrons. Number density means the number of electrons in 1 unit volume. And Vd is the drift velocity. So see, you have studied that velocity is equal to distance by time. So time will be equal to distance by speed. What is the distance? If an electron has to move from this end to the other end, the distance will be L. So if the distance is L, when we are calculating the time, this distance will be L. And speed here is the drift velocity. So this is our first equation. Now see, volume of a cylinder. What is the volume of a cylinder? We multiply the area with the thickness, that is the length. So volume is A into L. Now from the first chapter, we know quantization of charges. The formula of electric charge is N into E. But for all the electrons which are present in the wire, we'll be multiplying it with AN, right? So this is the second equation. Now what is the formula of the charge? I is equal to Q by T. Let us put in this value of time and value of the charge. So current is equal to charges NEAL. And what is the time? Time is L divided by Vt. See, length gets cancelled. I is equal to NEAVD. This is the derivation and it's called the relation between the current and the drift velocity, because here you have the electric current, here you have the drift velocity. So the question will be in this form: derive the relationship between the electric current and the drift velocity. So it's a very important question, and even more than your drift velocity derivation, this question has been witnessed. So write it down, write down this and mark this very important. Yes, class, please attempt your after class assessment. We'll be starting with Ohm's law in the next class now. All right, you all can leave now. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.